Now, we want to move away from simply encrypting strings to encrypting files. Okay, so this is going to typically follow the symmetric encryption format. That is to say that we will only be using a single key to run the encryption, and then we are going to be using the same key to run the decryption. So let's get started. So the first thing we're going to do is to create a file, a data file. It could be a .txt file or a .csv or any other file. But in this tutorial, we're going to create a .txt file and type in some information in this .txt file and call it our data file that we will be encrypting in this lesson. So let's do that. We go to File and you go to New. Of course, you could use a shortcut Alt Insert. Then we pick up File. Now let's give it a name. We give the file a name, data.txt, and press on Enter. So now let us literally write some information like first name, and then say it's equal to Alan, and then last name equal to Joe, and then put a password here, hello world 1 2 3. All right, so that's what we have here for our data. Now the next step is to create a new Python file, and with that we will be able to write our program for encryption and decryption. So let's go to this point where we start with so let's go back here and go to a new file, and this time we are creating a Python file, and let's give it a name, encryption. Okay, and then we press on Enter. Now we have encryption.py right here. So the first thing we have to do is to create a session key. That is the single key that we're going to use for the encryption. And then next we write a key into a particular file, and then use that key for the encryption, and then to the second step for decryption. So to help us do this, we need to work along with the cryptography module. All right, so the first thing we're going to do is that we need to import the module that would enable us to run the encryption. And the module we're going to use here is the cryptography module. So I'm literally going to type that, cryptography module. Okay, but one important recipe in this cryptography module we're going to use is the Fairnet. Okay, so this Fairnet is part of the cryptography module or library, and it enables us to be able to perform symmetric encryption and also even perform authentication to data. So it's literally going to enable you to generate a key that you will eventually be able to use to perform your encryption. Okay, so in order to be able to use cryptography module very well, you should have run pip install from your terminal. If you're doing this from your terminal, you can do pip install cryptography. Okay, so literally you type this in your terminal, or you can just do this in your PyCharm by going to File, and then you run down to Settings, and then you come to your project file. You see the Python interpreter. Now right here you would see all the packages that are installed. So currently we have cryptography installed, but if you do not have the package installed, just click on the add symbol, and then this time you are interested in installing the cryptography module, so you just type cryptography and that should pop it up, and then once you select that, you can do install package, and that gets you the cryptography module installed. Okay, so because we have it installed, we are not going to repeat the process. So now let's get back. Now we are going to use the cryptography module. So we say from cryptography, okay, dot fernet. Then we say import fernet. Okay. Now the next thing is that we want to be able to generate a key using the dot generate key method, okay, which is all in the cryptography library. So what we are going to do is to declare a variable called key, and then we say key is equal to fernet dot generate key. Okay, and then this means that a key is going to be generated based on this line, and that key is going to be stored in the variable key. So what we have to do is now to try and write this key in a particular file. Okay, so that is the next step. So we open a file, so we say with open. So this step we need to specify what is the file name, so literally the file that is going to hold the key. So obviously we can say, we can call it key, and then we need to give an extension to that file name. Okay, so you can either make it .txt or you can make it .anything. So we say .key. Just to make it a bit different from the variable we have declared, we can call it the session key. Okay, so session underscore key, and then let's give it an extension. Okay, so you can do .txt or even .anything. So I'm making it .key, and then now the next step is that you say it should write in bytes. Say write byte, and then we say as session key. Okay, so now we need to write the key to the session key file, and so we're just going to say session key dot. So we are going to say session key dot write, and then what are we writing in here is the key. Okay, right. So let us run this, and if we run this, we are going to generate the key into this file session.key. So let's just do that. Okay, and we've got no errors, so let's go find. By this time the key is already generated in our directory, so we can go to file is the session key.key. So what we're going to do is to open this file, and when we open, this is what we see. So there is one thing I said about the key, and that is that anytime we run the same line of codes here, we are not going to get the session key as the same. It will change. So notice we have the encryption here. When we run it, you would find that it changes. Okay, so we run it again. Now it begins with VKD. If we run this again, you realize that the key changes, the session key changes. So that is one of the characteristics of the fernet key. So when we store it in the file like this, then the next step we're going to do is to perform the encryption. Okay, so to avoid the key being changed over and over, then we need to be able to save it in a file so that we only work with the file, and then we can comment out the key generation line. To avoid the session key being generated differently anytime we run this particular code, we will comment out the lines that generates the code, and then assume that we are following the symmetric encryption approach, and then a user can equally load in a particular key and then use that key for the encryption, and then the receiver can equally load in the same key and use that for decryption. So let us comment this side. So after commenting, we need to load up the key so that we will be able to use that to perform our encryption. So what we do is now we load, we say with open and then quotes, and we call the file name session dot key, and then we read it as bytes. And then we read it in bytes. It's my session key. My session key is equal to this session key dot read. Now, if we want to see the session key that we have loaded, we can always print and then see what is in there. So we can just literally print the key, which is my session key. This is exactly the key that is stored in the session key file that we have actually loaded up here. Okay, right, so we go back, and then the next step is for us to use this particular key that we have loaded to perform the encryption. So to do that, we need to initiate the Fernet object and pass the key to it and store it into a particular variable. So let's say we store it into f, and we say f is equal to Fernet. Okay, and then set my session key. And then the next step for us to do is to open the file that we want to encrypt and then read it as a plain text. Okay, so let's make a comment, open the file to be encrypted and read it as plain text. Okay, so that's what we're going to do next. So we go with open, and then remember the file name we used is data.txt. Okay, so we're just going to call that. Okay, and we are reading it in bytes. As plain text. All right, so then we say, so the next thing we're going to do is to run our encryption using the .encrypt method. However, we are going to use the key that has been stored in F to perform the encryption, and we're going to save the result in some variable we are declaring right now as encrypted file. Okay, so we say encrypted file equal to f.encrypt. Okay, and we are actually encrypting the plain text. Okay, so we are encrypting my plain text. Okay. Now, the file has been encrypted based on this particular line. However, we can write the results into a new file so that we are able to view the encrypted file in a separate file. Okay, or we can also just print out the encrypted file, and then we can see that running within the space down here. So if we just said print encrypted file and then we run that, we will now see this is the encrypted, the content of the encrypted file. So if we do not want to just print out like this, we can also write it to a file. So let's comment out this and then comment out the printing of the session key right here. Okay, and go ahead and write the result to a particular file. Okay, so we go with okay, so we go with open, and then we need to tell what the file name should be. So we can just say encrypted file .txt, Okay, and then we choose how it should be written as bytes, and then we choose how it should be written as bytes and as my encrypted file. So the next step is that we are eventually going to have the writing being done, and what we are going to be writing is the result in the encrypted file variable. So we are just going to type my encrypted file dot write, and then we are writing the encrypted file, the results in the encrypted file variable to this particular encrypted file.txt. Okay, so now when we run this, we will be able to see the result of the encrypted file in the new file that we've created, which is called the encrypted file.txt. So let's do that right now. Okay, so the process finished successfully. If we go to file, the encrypted file.txt, let's see, and then here is it. So it's showing us now, now it's showing us that this data.txt file here, the content here, has been encrypted as this. So you can call this as the plain text, and you call this as the ciphertext. So next we're going to look at how to perform the decryption. The decryption is basically going to be like the reverse of what we have done for the encryption. Okay, so instead of using the .encrypt method, we are going to be using the .decrypt method. So comment out the lines that help us to perform our encryption, and then begin to program the decryption. So now we only need to comment out the lines that enabled us to achieve the encryption. But remember, we leave the key that we have loaded in the same, because we're going to use the same key to run the decryption. So let us continue. First step, we need to initiate the finite object and pass our key to it, and then store it in a particular variable. So we can do the same thing. We say f is equal to finite, and then finite is taking my session key. Okay, and then the next step is for us to open the encrypted file. So we go with open. Okay, so therefore, you can say file is equal to my encrypted file dot read. Will read the contents of the encrypted file.txt into the file variable. Okay, and then what we are going to do is to run a decryption on this file, and then store it in another variable. We can call it decrypted, and then at the end of the day, we will push the content of that decrypted variable into a new file that we will call as decrypted data. So let's move on. So this is what we're going to do. We say decrypted file is equal to, now remember we're using f because f is the one that is holding the key now. Then we perform decrypt, and then we are decrypting file, which is currently storing the content of the encrypted file.txt. And then what we do next is that we can straightforward print the content of the decrypted file variable, and then we can see that our decryption has been done successfully. However, we can also write this content of the decrypted file variable into a new file which we are now calling as decrypted data.txt. So let's see the first step. We can just print decrypted file, and then let's run and see the results. So you see here, first name Alan, last name Joe, password hello world 123. So let us write this content into a particular file. So what we do is we open encrypted data to decrypted data dot write. And what are we writing? We are writing the decrypted file. Okay, so that's basically it. And if we run successfully, then we can see that so now you see that we have the decrypted data as first name Alan, last name Joe, password hello world, and then the original data is first name Alan, last name Joe, hello password. So decrypted data shows up like this, and then this is the lines of code for the decryption. That's it.